horizontal and vertical. Remember, if you have a horizontal line, that means that the slope is equal to 0, and the equation of that line is always going to be, y is equal to some value, right? Whatever the y value is, that's going to be the equation of that horizontal line. And we also learned about vertical lines. In a vertical line, the slope is undefined if you're going to have division by 0. And the form of the equation of a vertical line is x is equal to some value. Okay, so a little rundown on that. The other thing to remember, we learned that point slope form of a line, y minus y sub 1 is equal to m times x minus x sub 1. And so we can find the equation of a line and if we're given two different scenarios, right? They could either give us 2 points. If they give us 2 points, then we find the slope using those 2 points. Remember, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's our slope. That gives us the m. And then we choose a point to use for y sub 1 and x sub 1. The other scenario they can give us, or another situation we can be in, is they give us a singular point and they give us the slope. And so in that case, we don't have to calculate anything. We don't have to find the slope. They gave it to us, and we don't have a decision to make on what point to use. We just have one. So we just plug those into that point slope form. M is the slope, y sub 1 is the y value of the point, and x sub 1 is the x value of the point. And so that's all you have to do for that. Questions on any of that stuff? Okay, so the form that we got our line in, once we worked it out in there, was the slope-intercept form, which is y equals mx plus b. And recall, m is our slope. That doesn't change. But this b value here is the y-intercept. It's where it crosses the y-axis. Any questions on that? So if they give us an equation written like this of a line, how can we find the slope and the y-intercept of that line? We'll take it in whatever form it is in right now. We want to put it in the slope-intercept form. So, slope-intercept form. And so to do that, we got to solve for y. You got to get y alone. Right now, we got 3x plus 6y on the left-hand side. We got 12 on the right-hand side. We just want to get y on one of the sides by itself. We want to isolate the y. And so we're starting with 3x plus 6y equal 12. And we want to get y alone. We want to solve for y. What do you think we should do? Subtract 3x from both sides. That's a good place to start. And then we'll end up with 6y is equal to 12 minus 3x. Now remember, we want it to be y equals mx plus b. So how will we write that? Instead of writing 12 minus 3x, let's write it as negative 3x plus 12. Okay. Let's keep in that form. Mx plus b. And if we want to get y by itself, what are we going to do with the 6? We're going to divide both sides by 6. Now, this is where things get a little different than what we've been doing. In previous problems we worked, we would just see if we could reduce everything, and we make this negative 2x, because everything reduces by 3, right? So it wouldn't be 2, it would be 1. It'd be negative x plus 2. All right, let's try this all again. All right, so we can reduce everything by 3. Let's work it out in parts. I'm confusing myself. And so reduce everything by 3, we'll have what? Negative 1 here, we'd have 4 here, and we'd have 2 there. So what we end up with, negative x plus 4. But this doesn't work out for our mx plus b. So what are we going to do? We can simplify the 402, but before we can do that, what do we need to do? We need to split it up, right? Instead of having negative x plus 4 over 2, we're going to have negative x over 2 and 4 over 2. So we rewrite this as y equals negative x over 2 plus 4 over 2. We can split that fraction up. It's the opposite of what you do when you're adding or subtracting fractions. How you combine them over the same denominator, we're going the other way. We're breaking it up into 2 to separate fractions. And so now, the 4 over 2, that's what? What's 4 divided by 2? 2. What about this negative x over 2? How can we write that? That way it's mx. What would the m be? Negative 1/2 times x. And so now we have it in our form of y equals mx plus b. And in that case, m, negative 1/2, and b is 2. So my slope is negative 1/2, and my y-intercept.
Do you have to do the steps where you have to split up the fractions? So that just went straight from dividing 6 to the last one.
Straight from here to here?
Yeah.
Well, I mean, in your head, what you're doing is you're splitting this up, right? You're doing negative 3x over 6, which is going to be negative 1/2 x, and 12 over 6, which gives you the 2. That's fine. I was just working everything else step by step. But if you want to split it up here, which is what I was really originally going to do, but I was like, well, they'll probably reduce first. But you could split it up first, and then you'll still get the same answer. Any other questions? I try to anticipate, like, what's the worst scenario you could get in sometimes. See what it would be like. All right. So we got that into slope-intercept form. This form that they first gave us, though, this 3x plus 6y is equal to 12. That is a type of form that they use for the equation of a line. Anybody knows what it's called? They may call it standard form in some places, but in our book they call it general form. But that is that form there. And that's what we're going to talk about now. Maybe. There we go. So the equation of a line is in general form when it is written as ax plus by is equal to c. Where a, b, and c are real numbers. They can be fractions. They don't have to be integers. They could be pi. They could be e. They could be any real number. The only thing is that a and b can both not be 0. One of them can be. In that case, it would be a vertical or horizontal line. Because you'd have x is equal to something, y is equal to something. But that is general form. Now, you may remember me talking on Friday saying that there's a form that we're going to go over that I don't like, and that's general form. I don't really understand the purpose because you have your slope-intercept form that you look at it and you get so much information. Oh, not H, B. You get so much information out of it. You get the y-intercept, you get the slope, and it's really easy to plot the line usually from that, to graph the line, just using that. But when you look at general form, what do you get? You don't really get much from it, right? It's just ax plus by is equal to c. You don't have the slope. You'd have to solve to get the slope like we just did. You don't have any intercepts. The only reason I can see why it might be useful is if you're trying to find, oh, that's 0. If you're trying to find your intercepts, because it's kind of easy to plug in a 0 for the x here, solve for y, a 0 for the y here, solve for x. So if you want to find both your intercepts, that's the only real reason I see for a general form. There might be some that I don't know about, but that's just, I mean, it's my opinion, really. But that's why I'm not a big fan of it. But it is something that we need to learn, just in case it's used somewhere else. And that's basically that. Any questions on that? So I've chosen the problem next. What I find useful about it. So we're going to try to graph the equation 2x plus 4y is equal to 8 by finding its intercepts. And so remember, if we find both the intercepts, we find the x and y intercept, that gives us how many points? 2 points. And if we have 2 points, we can graph the line. So if we want to find our intercepts here, we have 2x plus 4y is equal to 8. This can actually be reduced now that I look at it, but whatever. How do we find the y-intercept? How do we find the y-intercept? What do we know is true for all y-intercepts? X is equal to 0 because it's crossing the y-axis, and all along the y-axis, x is 0. So we're going to set x equal to 0. So we're going to do 2 times 0 plus 4y is equal to 8. Good. And that's going to result in 4y is equal to 8. Because 2 times 0 is 0. 0 plus 4y is 4y. And we'll divide both sides by 4 to solve for y. So we get y equal to 2. Questions on finding that? So what is my y-intercept? 0, 2. Yep. I had to think about it. Remember, it's x, y, right? So 0, 2. Depending on how they ask the question, sometimes they'll just ask for a y value. But if we want to plot it on our graph, we need to know that, okay, it's 0, 2. Any questions on that? What room I got here? Let's do it here. All right, let's talk about x-intercept. How do we find the x-intercept? Y is being equal to 0 for x-intercept. Crossing the x-axis, and all along the x-axis, y is equal to 0. So we're going to set y equals 0. And we're going to say 2x plus 4 times 0 is equal to 8. And we end up with just 2x is equal to 8. Divide both sides by 2. Then we get x is equal to 4. And so that means my x-intercept's what? 4, 0. Good. So you can see general form does lend itself pretty well to finding the intercepts. I think that's about the main, at least in my opinion, the main pro of it. So, do I have a graph? Nope. So let's make a graph then. How does that feel? That's not too bad. And I need to go 2 and 4, so 4 at least. And let's see where that gets us. So we got 1, 2, 3, 4, 6, 7. We got negative 1, 3, 5. And we got 1, 2, 4. And we got negative 1 right here. 2. Okay, so that's our graph. And so what we learned was the y-intercept is what? 0, 2. Oops. Don't look at that one. And our x-intercept was 4, 0. And so there are problems in the homework that are just like this, where they find the intercepts and then graph the function. And in those problems, they want you to use the intercepts. And so that's why I'm doing this problem to make sure you understand that. So understand that. So don't use any other points. Just watch the intercepts. That's going to create your line. So we have 2 comma 0. That's going to be where x is 2, 1, 2, and y is 0. That's going to be that point right there. And then we have the, oh, no, I did that wrong. Sorry about that. It's 0 comma 2. So x is 0, y is 2. So 1, 2 up here. I read the point wrong. There we go. And for our x-intercept, it's 4 comma 0. So we're going 1, 2, 3, 4, comma 0. Should be right there. And so now if we draw our line, yeah, let's try to do it like this. So connect those 2 points. We should have something like that. And we'll draw it for you, so you don't have to worry about that. And then we have a drawing right here of it, which is in your notes as well. Recall it. So that's all you gotta do. We can figure out the slope if we want from there. Because we have 2 points now, so it goes down 2 over 4. That'd be what? -2 change in y, and 4 change in x. So that would mean it would be -1/2. So you can use the graph to find the slope and all that for that too. Or use the point. The 2 points, 2 intercepts, which is basically what we did with the graph. Any questions on any of that? All right. Get rid of my background. So let's talk about parallel and perpendicular lines. So these are 2 special, I guess, relationship between lines that can happen. So you probably heard parallel lines, spelled P-A-R-A-L-L-E-L. Always remember that you need 2 L's because they're parallel. That's how I always remember that. A lot of people misspell parallel, me included, so I started doing that. Parallel lines are lines that run next to each other but never intersect each other. People always think like train tracks, right? So your train tracks run next to each other, and they never intersect each other. I mean, until you get to like a switch or whatever. But on the most part, train tracks don't run into each other. And so that's how they think of parallel lines. But what really makes parallel lines mathematically is, does anybody know?
Yes.
They have the same slope. So if this is line 1 and this is line 2, the slope of line 1 is going to equal the slope of line 2. And there's one other thing that has to be true for them to be parallel lines. They have the same slope as the big one, but there's a tiny thing that has to also be said that is short or something. Does anybody know what it is? No, that would go with the slope, because the slope's got to be the exact same, right? So it has to have the same sign, it has to have the same magnitude too, same value. The other thing is they have to have different, and it's kind of silly, but they have to have different y-intercepts. Does anybody know why that is? They overlap. They'll be the same line, because what this does is this means that they're not the same line. You could say that too. You could say they have different x-intercepts. The common thing is to say they have different y-intercepts because you use y equals mx plus b. And so we talk about the slope and the y-intercept the most for lines. But you could just say that they have different points. So you can say if they have a different x-intercept, that works as well, because it just means they have different points. They kind of start in different locations. So I mean, a line doesn't start or end anywhere; it keeps going. But you know what I mean? Like it's shifted over. And so that's the 2 things that need to be true. And they have different slope and different y-intercepts. And that will make lines parallel, which we probably right here. Two non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. Now it's weird that they say two non-vertical lines. Why do you think they say that?
It's vertical, it doesn't have a slope.
It doesn't have a slope. The slope is undefined, so it can't really be equal to each other. But if you have two vertical lines and they have different, they don't necessarily have to have a y-intercept, right? So if they have different x-intercepts, then they would be parallel. As long as they don't have the same x-intercept, then they would be the same line, not parallel whatsoever. They're constantly running into each other. The same thing for horizontal lines. If you have two horizontal lines, they both have a slope of 0, so it's equal. You just need them to have different y-intercepts, so that way you're not on top of each other. Any questions on that? Nope. And there's another example. I'm not sure why it has two pictures, but there are. And that leads us to this. If you have a line, or if there is a line, that's written as 2x plus y is equal to 6. That's the equation of a line given to us. And we want to find a line that's parallel to that line, but contains the contains the point 2 comma negative 3. How can we do that? We could graph it, yeah, and then do what?
I was gonna say
Plug in what points?
plug the x and the y into x and y.
So this may not even be a point on this line. It probably won't be, actually. Because if our line is going to be parallel to that one, we don't want this line to contain that point. Right? Because what we have 2x plus y, right? And I'm just drawing this like, this is maybe not even true, but let's say this is 2x plus y equals 6, right? We want to find a line that's parallel to it that contains 2 comma negative 3. That's what we want. What do we know about this line and this line? They have the same slope. So if I can find the slope of this line, I know it's going to be the same slope as this line. And remember, to find the equation of the line, we just need either 2 points or a slope and a point. And so they gave us a point. How can we find the slope? Find the slope of this one. Oh, I wrote them both as 1. But yeah, 2. Well, I guess it is 1, because m sub 2 is equal to m sub 1. That's the parallel. So that's all we gotta do. And how do we find the slope of this line right here? We did that earlier, right? I mean, there's a couple of ways to do it. Probably the easiest way to do it is solve for y. Get it into y equals mx plus b, slope intercept form, and the slope will just be there for us to take. So if we do that, and we subtract 2x from both sides, this one's not too bad. We'll end up with y is equal to negative 2x plus 6, and thus its slope is what? Negative 2 over 1, or just negative 2. Right? And so that means the slope of our parallel line is also negative 2. So now we have the slope of our line. We have a point that's on our line. So we're going to plug it in to our point slope form. Y minus y sub 1 is equal to m times x minus x sub 1, which is going to be y minus a negative 3 equal to negative 2 times x minus 2. And we just got to work that out. So we'll get what, y plus 3 here. Let's distribute that -2 to the x and to the -2 as well. And so this is going to be -2x plus 4, right? It's -2 times -2, positive 4. And then we subtract 3 from both sides. We'll get y is equal to -2x plus 1. And so we can see we got our equation of our line in slope-intercept form. Its intercept is 1. Its slope is -2, which matches the slope we got for this one. And its intercept's different, so yeah, looks good to go. That'll be our answer. Any questions on that? All right. Here we go. Okay. The next relationship of lines, which you may have already guessed, but you probably heard of it before, is perpendicular lines. Right? Perpendicular lines are lines that intersect once, and they intersect at 90-degree angles. That's what makes them special. Relationship to each other. And so, perpendicular lines will share a point, right? They will share one point. That's the point where they intersect each other. So they do share a point common, whereas parallel lines don't share any points. And the other thing is, does anybody know? We label this L1 and L2. Then the slope of 1 is equal to the negative reciprocal of the other slope. Or another way to write it is it's negative, that's the 2 raised to the -1 power. So I think of it that way. So it's the negative reciprocal. People say flip it, change the sign. That's fine if it helps you remember it, but the actual term is the negative reciprocal. And another way of saying that is two non-vertical lines are perpendicular if and only if the product of their slopes is -1. That means that m sub 1 times m sub 2 is equal to -1. Which is, if you solve that equation for m sub 1 or m sub 2, you'll get the same relationship we just got. If you would divide by m sub 1 or m sub 2, right? Any questions on that? No? So people do well with perpendicular. Well, people do really well with parallel lines. People do a little bit less well with perpendicular lines. But what really gets people is the fact, this non-vertical thing we got going on. Well, let's come back to that. And the reason being is, if you have a vertical line, what's going to be perpendicular to a vertical line? What kind of line?
Horizontal.
A horizontal. So if you're given a vertical line and ask you to find a perpendicular line, your line is going to be horizontal. If you're given a horizontal line, what kind of line is going to be perpendicular to that one? A vertical. And so those you got to kind of think about, because if you try to find a reciprocal of a slope with 0, you get undefined. And if you try to find a reciprocal of a slope that is undefined, you're still undefined, right? So that's the ones that give people the most problems. You just have to remember or picture it. I picture it in my mind. I always do the arm thing, but you can draw it just to give you that little extra edge of, okay, well, what do I need? What's going to be perpendicular to that? So this is kind of a repeat of what we just said. If two non-vertical lines have slopes whose product is -1, then the lines are perpendicular. Yeah, that's just restating the same thing. So if you want to test to see if two lines are perpendicular, All you gotta do, multiply their slopes. If you get -1, they are perpendicular. If you don't, they aren't. So if I want to test, are the following lines perpendicular? I don't know if I'm going to fit the word. And so let's say you have two lines. You have y is equal to 2/3 x plus 6. And you have y is equal to 5 halves. Let's say -5 half x plus 7. How are we going to determine those two lines are perpendicular? Just going to take the two slopes, multiply them. So if I take 2/3 times -5 halves, what do I get? Well, I can reduce. That's going to be 1, 1, but then I end up with -5/3, which doesn't equal -1. So those are not perpendicular. If we had right in red, 3x and -1/3 x. Are those two lines going to be perpendicular? Just got to multiply it out. 3 times -1/3. Oh, we can put this as 3/1. The 3's will reduce here. What else? -1/1 is just -1. And so yes, those lines are perpendicular to each other. That's all you got to do. I think there are some like that in the homework. And what's this? Okay, that's just to show you the slope thing. Any questions on that? So let's try some. Or just try one. I can make up some too. Well, how are we going at time? Oh, we're good. Find the equation of a line perpendicular to a given line. So we want to find an equation of a line that contains the point 1, -2. So our line, our new line, contains 1, -2. Excuse me. And it's perpendicular to the line x plus 3y is equal to 6. And it wants us to graph the two lines, but we can just use some points. I think we understand graphing stuff. So what do we need to do? We're going to figure out the slope of what? The original line that they gave us, and then we can figure out the slope of our line. Right? So I'm going to use some different symbols and stuff like that, but I'll explain it to you as I go. It's just something that the book doesn't use. It's really something that I just came up with. So, but it might help you. So that's what I like to do. So we have our original line, x plus 3y is equal to 6. And so we want to find the slope of that line. What's going to be the slope of that line? What are we going to do? We'll put it in slope intercept form, which means I got to solve for y. So subtract 6 from both sides. You get 3y is equal to -x plus 6. And we're going to divide by 3. I'm going to do this in parts right now like that. And so we're going to have y equal to, what is -x over 3? How are we going to write that? -1/3 x. And this is going to be plus what? 2. So our slope is what? -1/3. Any questions on that? So this is the thing that I change up. It's hard to say, well, that was our original slope. And we want to write m for our new slope, but what I do is I write m with a little sub p, meaning that it's the slope of my perpendicular line. If you want to use m sub 1, m sub 2, that's fine too. I just think that gets confusing. Which one's 1 and which one's 2? So I like to write m sub p to mean that's the perpendicular line. Okay, so we could write it out in all the ways to do it. It would be like -1 over -1/3. But remember, what we're going to do is we're going to change the sign on that thing and we're going to flip it, right? So we're going to reciprocate it, flip it, and then change the sign, which means multiply by -1. And so the slope of our perpendicular line is going to be what? Just 3. So now we have the slope of our perpendicular line. They gave us a point. I think it was 1, -2. Yep. 1, -2. So we got a slope. We got a point. We're all set to go. Y minus y sub 1 is equal to m times x minus x sub 1. You know, y minus -2 is equal to 3 times x minus 1. Which is going to be y plus 2. Well, let's distribute the 3 while we're here. It's going to be 3x minus 3. Remember to distribute this 3 to the x and to the constant there, the x value. That's one thing that people always forget to do. And then we're going to subtract 2 from both sides. And so we're going to have y is equal to 3x minus 5. And that's going to be the slope. Well, that's going to be the equation of our perpendicular. Now, if we wanted to write that in general form, what any questions I'll find in that first? All right, if we want to write that in general form, how would we write that in general form? Anybody know?
Subtract the x.
We subtract the 3x from both sides. And so you could write it as -3x plus y is equal to -5. Or in the notes, I changed the signs. And so it's 3x minus y. But in my mind, both of these are good. Any questions on that? Cool, I got enough time. Let's say you want to find honestly, it's probably quicker if I just do this. Equation of the line. Oh. I think it doesn't shrink until I do that. Oh, that's what it is. 1 second. Maybe it would have been quicker if I just wrote it. There we go. X equals 4. Maybe. So if I want to find the equation of the line perpendicular to the line, x equals 4, taking the point -2, 6. So if they give you a line that's not in like, it doesn't have an x and y, you know it's either a vertical or horizontal line, right? If it's x equals 4, what type of line is that? As a vertical line. So that means it has undefined. That means it has undefined slope, right? So I can't really work with the slope there. But if it's a vertical line, our line is perpendicular to it, what kind of line are we going to have? So our line is going to be a horizontal line. So that means it's going to be written as what? What's the form of a horizontal line equation? Y equals something, right? Questions on that? How do we know what that something is? Y equals what? How do you know it's 6? We contained a point negative 2 comma 6. The y value is 6. So our equation is going to be y equals 6. Good. Any questions on that? We'll do one more. Let's go with that. These are line parallel to the line. Let's do y. Yeah. Don't want my order pair separated like that. There we go. All right, so let's say we're trying to find the equation of the line parallel. Y equals negative 20, containing the point 3 comma 0. Now notice we have switched it up. We're not talking about perpendicular, we're talking about parallel. So that means it's going to be what? The same slope, right? The same type of line. So what type of line is y equals negative 20? As a horizontal. And so our line is going to be what? It's going to also be horizontal. And so we know it's going to be y is equal to some a. What's the y value that we're going to use? 0, yeah, because we have a point on our line, which is 3 comma 0. The y value of that is 0. The y is equal to 0. That's going to be the equation of our line, which is the x-axis. That is the line we're talking about. Because there'll probably be a quiz coming soon, and